All right, so we've learned quite a bit in this section. Let's try to do a summary of all that we've seen so far. So first of all, we talked about passing parameters into the resolve function and the different ways in which this can be done. There is a whole host of different parameter classes that you can use. So for example, we have named parameter. That's when you know the name of a constructor parameter and you can provide a particular value. Then there is a typed parameter, which instead of searching for the parameter by name, it searches for that parameter by type. And then we have the more complicated variety of a resolved parameter. Now this is something where you can actually try to resolve the parameter depending on, for example, a particular predicate that you specify. So you get the parameter info argument and you can investigate the parameter type, you can investigate the all sorts of different things, and then of course you can provide the value. And once again, both the predicate as well as the value you're going to provide can be dependent on both the parameter itself as well as the context, and this introduces interesting new possibilities. Like for example, if you're taking 10 different parameters, you can programmatically assign them depending on where they are and so on. So this is once again a more advanced feature, but it is something that's available if you want to use it. Now these parameters, everything that we've seen, all of these types, they're passed at registration type, and this isn't the only way that you can do this. So certainly at registration type, you can sort of hard code the parameters that are going to be passed for every time the component is instantiated, but there is a different way, and that is to use lambda expression components to pass the value not at registration, not when you're calling register type, but actually doing it at resolution time when you actually resolve the service or you resolve a particular component. So in addition to that, here is what we've seen in terms of injection. So we saw property injection, and that's basically this idea of lambda registration. So instead of register type, you invoke register, and this register takes a lambda, which takes a component, iComponent registration interface, and what it can do is it can let you specify explicitly what you want to construct. So in this case, we're saying builder.register, and we're saying that given the context, every time somebody wants a child, they're going to get a new child, and the parent property is going to be assigned to the resolved value. So that's the reason why the lambda takes this argument, because then inside the actual lambda you can resolve different types. Now it's important to realize that you should totally be using this context when resolving types. You should not be using the container. You shouldn't drag the container into a closure. I know it might make some sort of bizarre sense to do that, but you should be using the lambda argument if you need to resolve something. There is also a possibility to auto-wire all the properties, and this basically means that the autofact container looks at all the public properties of a particular type and it tries to inject them as well, in addition to injecting what's in the constructor. Now it's also possible to specify a particular property. So in this case, you can specify the name of the property and give it once again specify a value that you want to assign. We also looked at method injection, which is, well, a similar idea. It's using the same API. So you say builder.register, which takes a lambda. So we're not doing register type, we're doing builder.register. And here, what you would do instead is you would create the component. Then if there is some method that you need to invoke for example, assigning the parent of a child, you would simply invoke it here right inside the lambda, once again using the context to resolve any dependencies that you might need, and then you return that type, and that becomes the lambda that gets invoked whenever somebody needs to invoke and inject a child into some other component. Now, in addition to this, if you, for some reason, if you cannot use a registration lambda, there is another thing that you can do called an activating event handler. So essentially what you can do is after you register the child, there is this event. It's a lifetime event called onActivated, and what happens here is, once again, this is a place where you can resolve, for example, something out of the event. So you can say e.context.resolve, you can get a parent, and then you can get the instance that you're currently building up, and you can say set parent there, but thereby you're effectively doing the same kind of method injection once again. Okay, so let's talk about scanning for types. So essentially this saves you a lot of time by auto registering every type in the assembly. So you just say builder.register assembly types assembly, and every single type is going to be registered in the dependency injection container. But you can also do filtering, which feels kind of like LINQ. It feels kind of like calling LINQ operators. So for example, you can specify a where clause where you only register the types where the type name ends with log. And the T here, the lambda argument, is a system.type, so it's just an ordinary type that you can introspect using the reflection API. Nothing particularly magical about any of this. As always, we have the as clause, which allows you to register a service. So if you want to take a bunch of components and if you want to register them as a service, then you can say builder.register assembly types, where you filter out the actual types and you register them as ilog, for example. So there is also except, so this is the reverse of as, in the sense that well, the reverse of where, to be more specific, because you throw away the types that you don't need. So you can register every single assembly from the assembly types except this particular type. Now, it's also possible to provide an alternative handling mechanism. So, for example, instead of just saying except ilog, which basically tells you to ignore the ilog, what you can do is we're going to do the default registration for every component except the console log, and in the case of the console log, we're going to register it as an ilog. So instead of throwing it out completely, you just customize the overall registration process. Now, in addition, we saw the use of as self, and essentially as self registers the component as the component itself, in addition to any kind of service that you're providing. So if you want your console log to be available as a console log component and as an ilog, then you have to call as self as well as calling the as function. So both of those are required. And we also saw as implemented interfaces. This basically grabs a type like a console log. It looks for all of the interfaces which this type implements and then registers each of those interfaces as a service. All right, and finally we looked at modules. Now, a module is just a self-contained definition of component registrations. It exists in a separate class which extends the module class. So it's very convenient if you have a very large application made up of several assemblies, because then each of those assemblies can handle its own registrations, but then those can be plugged into the overall container, because typically in an application you just have one single dependency injection container, but you might want to spread out those configurations over several classes in different assemblies. So essentially you can get the types from all the modules. That's just builder.register assembly modules with the assembly. So in this case, instead of just looking for every single type, what it's going to do, it's going to look for every single class which extends the module class. And similarly, it's possible to load a specific module. So in this case, you say register assembly modules, and then this is a generic function. So here you provide the type of the module that you want to register, and that registers just the individual module. So essentially, it goes into the module and it executes all the relevant code for performing registrations and that sort of thing.